Okay, so let's talk about the types of angles within a circle. So if you have a circle, okay, this angle formed using the center of the circle is known as a central angle, okay, central angle. And the measurement of the central angle is the same as the arc measurement. So remember, when you measure an arc, you measure it two ways. You measure the length, and then you measure the curvature. The curvature is measured in degrees. The length is measured in distance, like meters, inches, whatever. So if you have a central angle, so say this is, say, 80 degrees, okay? The arc, its associated arc has the same measurement as well. So it has an 80-degree curvature as well. And that's a central angle because it involves the center of the circle. So the measurements are the same. But that's not the only angle that we have in a circle. We also have an angle known as an inscribed angle. And the inscribed angle is an angle formed like this, whose angle is on, or the vertex is on the edge of the circle. And the relationship between the inscribed angle and its intercepted arc, the arc that's associated with it, is this. The arc is half the angle, so if you get 1/2 the arc, you get the angle. Or another way of saying it is if you double the angle, you get the arc. So if the angle is 50, the arc is 100. Okay. And vice versa. If the arc was 120, the angle would be 60. All right. So let me show you a problem type that you may get. And these are problems that were in your homework packet that I gave out before we left for the little COVID break, if you will. So let's look at problem number 1. Okay, problem number 1 wants to know the measurement of this angle right here. Okay. So the first thing I would do is I would draw out the angle. And this is where, like, if you have colored pencils or highlighters, they'll come in useful. So here's the angle, and this is its associated arc. And if the arc is 98 degrees, the angle is half that, which is 49 degrees. All right. And this is only for inscribed angles. Does everyone understand? All right. So let's have you guys do an example. I want you guys to do, let's see, let's have you guys do, let's do number 3. Find this angle, E. Find that angle. Okay, does anyone have an answer for me? What would that angle be? Make sure you unmute yourself to tell me the answer. Anyone have an answer?
No, sir.
Okay, so let me walk through it. So the first thing you want to do is draw out the angle on the diagram. Okay, so this is its arc. So what's the measurement of the arc? What would the arc be?
122.
122, good. So if the arc is 122, what does that make the angle?
Wouldn't it be 122 minus 40, 90, something like that?
Remember, it's half that. So the angle is half the arc. So if the arc is 122, the angle is what?
Hold on, I'm getting a calculator. 61.
Yep. Good. Are you getting it?
I'm getting it a little bit.
All right. Now, let's look at number 4. Number 4 says find the measurement of the arc, WXY. So first thing to do is highlight which arc you're talking about and see what angle is associated with it. So we want to find the measurement of this arc, WXY. So what angle is the arc of that? What is the associated inscribed angle? What's the measurement of that inscribed angle? Ms. Warren, what is the measurement of the angle? What? Well, what is the angle associated with that arc? Do you not see it?
105.
What is this thing right here? That's the angle. So what's the measurement of the angle?
102.
The angle is what measurement? The angle is 105. So what does that make the arc?
105.
No, the angle and the arc are not the same measure. It's an inscribed angle. What is the measurement of the arc?
Isn't it twice that size?
Yeah, so what would it be?
So 210.
Yep. Does everyone see the relationship? The arc is double the angle, or the angle is half the arc. Whichever relationship is easier for you to understand. All right. Let's look at the problem type number 5. So this is what you're going to have to do. These problems are a little bit more difficult because you're going to have to look at these diagrams a little bit more involved, okay? So in number 5, I'm asked to find this arc length right here, okay? Now, the only thing I've been given is that this angle is 40. So this angle right here is 40. So if that angle is 40, what does that make this arc right here? What does that make the arc? Anyone?
Would it be 80?
Yes, it would be 80, correct. So,
What?
okay, so the angle is 40. How is the angle and the arc related? Remember, the angle and the arc have a relationship. The arc is double the angle. So if the angle is 40, the arc is 80. Okay. Now, That gets me the arc measure from here to here. But I want to know the measurement from here to here. How do I do that? Well, what is this, guys? What's the measurement of this from here to here?
180.
180, because it's half a circle, right? It's half a circle. Now,
So the other side would be 100.
yep, right. So if this piece is 80, that makes this piece 100. Okay. So this is what you're going to have to do. You're going to have to sort of look at this diagram and write out what you know, okay? Do number 6 for me. Those of you who just joined, we're doing number 6. Okay. So number 6, I'm asked to find this angle. So in order to find the angle, I need to know what the arc is. If I knew what the arc is, I can figure out what the angle is. But I know from here to here is 62. And all the way around is 180. So that makes this piece 180 minus 62.
118.
118. So what does that make this angle?
Half of that.
Yep, which is
59.
59. Good.
Yeah.
Excellent job. Any questions? All right, let's see if y'all can do a couple of easy ones. Let's see if y'all can do number 8. Number 8's not that difficult. I think you can, if you look at it, you can get it.
Mr. D.
Yes. What now? You broke up. Okay.
Said you got pencil?
Mm-hmm. So, number 8. Okay. How do you think we're going to tackle number 8? So the question is, what is this angle right here? So the first thing I do is highlight the angle that I'm talking about. So in order to know the angle, I need to know the arc, right? So how do I find the measurement of the arc? Think about it. If the whole circle, what is the degree of an entire circle?
360.
360, right? And I know from here to here is 69, and from here to here is 115. Okay, so how do I figure out the rest of it?
360 minus what's given.
Yes. So what do I get when I subtract what's given from 360?
179.
Is it 179? No.
Or 176.
176, yeah. So if this arc is 176, what does that make the angle?
Half of that?
Half that, which is
88.
what now? 88, you said?
Yes, sir.
Perfect. So any questions on how we're supposed to be doing these problem types? Are you getting a hang of it? Okay. Now let's go back to a previous problem that we just did. Let's look at number 4. Okay, number 4, we found it to be this arc to be 210. So can anyone tell me so let me draw a diagram. So we found it from here all the way to here is 210. Can anyone tell me what would x be? How can we figure out what x is?
Would it be 75?
How'd you get it?
I took 360 minus 210 and I got 150.
Okay, good. The rest of the circle must be 150, right? Good. And keep going. How did you get 75?
I halved it.
Okay. So what is the sum of angle X and angle R? If I add the measurements of angles X and R together, what do I get?
Oh,
180, yes, 180. Now, what do we call angles that add up to 180? Starts with an S.
secant?
Hmm?
Secant? Something like that?
Not secant. Secant is a line.
Mhm.
What do we call angles? This is from the beginning of the year, guys. We've been talking about this throughout the year. What do we call angles that add up to 180? Starts with an S.
Supplementary.
Supplementary, yes. Supplementary, yes. So angles X and angles R are supplementary. Now, notice something. This is known as an inscribed quadrilateral. Okay, it's quadrilateral because it has 4 sides. Quadrilateral because it has 4 sides. And it's inscribed because all of the vertices of the quadrilateral are located on the circle. Remember we talked about inscribed polygons being within the circle. The next theorem that you have says that if you have an inscribed quadrilateral, the opposite angles are supplementary. Okay, so for example, in this quadrilateral, R and X are opposite. So if they're opposite, they are supplementary, which is what we just showed. Okay. In addition, W and Y would be supplementary because they're also on opposite sides. Okay. So that's the next theorem that you need to know about inscribed angles. That if you have an inscribed quadrilateral, That means all the vertices are on the circle. The opposite angles are supplementary. All right, now let's talk about one more theorem. Let's say we got a circle. Okay. Okay, like this right here. What would be the measurement of this arc? What would be the measurement of this arc? I mean, of this angle, sorry.
90?
How did you get it?
Because it's 180.
What's 180?
The half of the circle.
Mm-hmm. So this half a circle is 180, right? And this angle is the inscribed angle of that arc. This angle is the inscribed angle of this entire arc. So the arc is at 180, the angle is half that, which is 90. What do we call an angle that is 90 degrees? What is the name for that angle?
No, right angle.
Right angle, right. So this is 90 degrees. Now, what does that make? What type of triangle does that make this triangle here?
The right triangle?
Right triangle, right. Because if we have a triangle with a 90-degree angle, it's a right triangle. And that's the next theorem. If you have a triangle inscribed within a semicircle, then that triangle is a right triangle. A triangle inscribed within a semicircle is a right triangle. Okay. And remember, up to now, we said that you cannot assume a triangle is right until you see this little square, right? But there's an exception to that rule. If you get a diagram of a circle and you're given an inscribed triangle within the semicircle, if you're given an inscribed triangle within a semicircle like that, okay, they may not put a square here because it's understood to be a right triangle, because that's the theorem. That's what the theorem says, that if it's inscribed within a semicircle, then you have to assume it's a right triangle, and we showed that. Okay, so you may get a triangle like this and it may not have a square in it, but you are to assume that it is a right triangle. And this brings up quite a few problem types, okay? So a problem they might give you is something like this. This chord is 8. The length of this chord is 8. The length of this chord is 6. What is the radius of the circle? What's the radius of the circle? Well, what is the relationship between the three sides of a right triangle? How are the three sides of a right triangle related? Famous theorem. It starts with a P. Does anyone remember the name of that theorem? Pythagorean Theorem. That's only true for right triangles. But now you know that this triangle right here is a right triangle. So you can use the Pythagorean Theorem to find this side, which is also the diameter of the right triangle. Okay? So use the Pythagorean Theorem. Remember, one side squared plus the other side squared is equal to the hypotenuse squared. So that makes this entire length 10. So what is the radius? What is the radius going to be if the entire length is 10?
5.
5, yeah. So these are the types of problems that you'll get with triangles inscribed within a semicircle. Okay? They're going to assume that you know that once a triangle is inscribed within a semicircle, it's a right triangle, and then all the relationships of right triangles will be assessed. Okay? Any questions? All right. So, inscribed angles, couple take-home points. Number one, inscribed angles are angles that are on the edge of the circle, and the relationship is this: if you double the angle, you get the length of the measurement of the arc, or if you half the arc, you get the measurement of the angle. Number two, if you have an inscribed quadrilateral, the opposite angles are supplementary. That's the second relationship. The third relationship, or the third theorem that you need to know, is that if you have a triangle inscribed within a semicircle, that triangle is a right triangle. Now, let's look at some problem types. Let's see if you can do number 10. Number 10 is pretty straightforward. Okay, solve for x. Okay, so what do we do? How do we write an equation to solve for x? So we have to let 128x equal something in order to solve for x. So how are we going to write the equation? Well, what are you given? Okay, you're given this. You're given the inscribed angle is 64. So what does that make this arc measure? What does the arc equal if the inscribed angle is 64?
160.
Not 168, but 128. So you would say 128x equals 128. You're given that this equals 128x. So 128x equals 128. Solve for x. Okay. Solve for x. Okay. Any questions on how we did that? All right, let's look at number 13. All right. Number 13. Let's look at this problem. If C is 106, what does that make A? What does that make A? Remember, we just talked about this.
106.
What?
106, right?
No, it wouldn't be 106. I did, when I said we have an inscribed quadrilateral, it's not, the angles are not the same, but what? The angles are not the same, but what? We just talked about this. What do these two angles add up and give you?
Don't they equal 180?
So it's 74.
Yeah, they equal they equal 180. So if this is 106, what does that make A?
74?
Yep, 74. Good. So if this guy is 74, what is the associated arc with this angle? Well, the arc is from here all the way to here. So 10x plus 68 equals 148. Because remember, if the angle is 74, the arc has to be double that. So that'll be 148. So 10x plus 68 equals 148, and then you solve for x. Any questions? All right. So you get a good hang of these inscribed angles and the relationships and everything we talked about. So the more practice that you do, the better off, I mean, the more you'll get a better grasp of this concept. And it is important that you get a strong grasp of this concept, because the section after this starts dealing with secants and tangents, and you're going to be dealing with major arcs, minor arcs, and all sorts of whatnot. So if you can't relate the arc to the inscribed angles, relating the secants and tangents to major and minor arcs is going to be near impossible. Okay? So make sure you get a good grasp of this concept. Any questions? All right. Well, if there's no questions, then I will either see you tomorrow at 10 or tomorrow at 2. All right. Okay, if you need anything, let me know.
Sure.
Okay. Have a good afternoon, guys.